Okay, for example number 2, we're looking at SAT versus ACT. And the SAT has a mean of 500 with a standard deviation of 100. So I'm going to call the SAT is X. And I'm going to say that the mean is 500, X bar is 500. Standard deviation, SX, is 100. And the actual score that I got on the SAT was 550, so X is 550. And the ACT is going to be Y. And so the mean of Y is equal to 18. That's the average score on the ACT. The standard deviation of Y is 6. And his ACT score was a 30. So Y equals 30. Now, before I even do the calculations here, I'm looking at this, and on this one he scored the average is a 500 and he scored a 550. He scored a little higher, right? The standard deviation is going to matter too, but just looking at this logically, the average here is an 18 and he scored a 30, which is way higher. So like my general feel is that the ACT is probably the more impressive score here, but we got to do the calculation just to make sure because they're on a different scale. So to know for sure, we need to look at Z-score and calculate and see which one's higher. So the Z of SAT is going to be 550 minus 500 over 100, which is 50 over 100, which is 0.5. So the Z-score of X is 0.5 for the SAT. So he did a little above average. The Z-score of Y is 30 minus 18 over 6, which is 12 over 6, which is a Z-score of 2, which is much higher. So which score is better? The friend definitely had the higher ACT score at a 30. So my friend had a higher relative score. Had a higher relative score on his SAT. I mean on his ACT. Yeah, he did the ACT. So his relative score was much higher on the ACT than mine was on the SAT. So that is example 2 from outline 5.